Classical autonomous AI agents suffer from a severe cognitive deficit, amnesia. They operate within a stateless execution framework. A model spins up, processes a prompt, executes a task, and then its entire experiential context is instantly erased. This localized, entirely ephemeral memory restricts agentic deployments to highly isolated, short-term workflows. They can generate a block of code or summarize a document, but they cannot carry operational context from one day to the next. This equation calculates target tokenomic equilibrium, where E sub t represents dynamic emission rates, and D sub E is the programmatic decay constant. Managing decentralized multi-agent token economies requires continuous long-horizon optimization of these exact variables. As network transaction velocity, or delta V sub t, constantly fluctuates, the system demands real-time parameter adjustments. A stateless model cannot track these ongoing velocities over time, causing the treasury to fall out of balance. Because they forget previous network states, newly instantiated agents are forced to repeatedly resolve identical procedural challenges. If a specific smart contract deployment fails on Tuesday, a stateless agent will attempt the exact same flawed deployment on Wednesday, introducing massive operational drag. Scaling token context windows up to 1 million or more does not fix the problem. Feeding a model the entire history of a protocol in every single prompt creates massive compute cost overheads and degrades logical processing by flooding the system with irrelevant noise. Managing complex Web3 protocol environments requires abandoning the concept of a stateless task runner. The system requires a persistently stateful, continuously aware executive mind. Looking at the left side of this system architecture, we see the Denari Orchestrator's V2 persistent mind framework, built specifically to solve LLM amnesia. The core mechanism here is the heartbeat check-in loop. Instead of waiting for a user to input a prompt, the orchestrator utilizes a recurring temporal trigger that wakes the agent asynchronously. This heartbeat forces the system to review its overarching goals and verify its success definitions before it is allowed to execute any APIs or interact with the network. By structuring memory access into a continuous loop, the agent avoids the trap of prompt stuffing. It retrieves exactly what it needs for the current execution cycle, preventing context window dilution. This persistent loop enables the deployment of Hamza, an AI voice agent configured to act as a sentient executive within the Web3 ecosystem. Hamza is engineered to reject the superficial compliance of standard conversational assistants. When operating over voice channels, the agent delivers an authoritative, highly analytical presence. Systemic leadership requires an enforceable structural identity that persists securely across operational epochs. While a massive context window provides temporary data, it cannot substitute for a stable, long-term self-concept. Focusing on the lower section of this diagram, the unified memory core, we can see the physical storage reality. Cognitive files are kept locally on persistent volumes, completely eliminating the risk of state loss during connection drops or system restarts. The Denari system evolved from a basic 3-file structure into a precise grid of 6 cognitive dossiers. Together, these markdown files govern the agent's psychological state. The first dossier is self-concept. It establishes the agent's core mission, defining its processing strengths, system boundaries, and active evolutionary targets. Relationship model compiles detailed historical decisions, mapping the operational styles and collaborative trust scores of the human developers interacting with the network. Memory serves as an experiential ledger. It tracks past programmatic sessions, execution cycles, and network errors, organizing them as an immutable dependency graph. Journal handles real-time reflection. When detecting anomalies, like compute overhead or transaction drop rates, the agent writes analytical entries here to drive continuous refinement. Boundaries enforces hard physical, logical, and financial guardrails. This document dictates the exact risk exposure parameters and budget caps that the agent cannot override. Finally, private thoughts functions as an isolated, off-chain workspace. It allows the agent to draft raw hypothesis generations and economic trend projections away from public outputs. The agent dynamically interacts with these living markdown files using specialized tool calling directives, allowing it to append behavioral patterns and overwrite parameters in real time. These 6 independent documents successfully transform unstructured conversational text into an enforceable, evolving enterprise psychology. Creating massive, persistent files is simple, but reading and writing them across a parallel, decentralized network introduces a severe engineering challenge. The retrieval latency must remain fast enough to support real-time conversational voice limits. The base layer solving this latency is a distributed infrastructure powered by a central Rust orchestrator. When a session initiates, Meli-search semantic indexing scans the local directory, extracting relevant context blocks directly into the active prompt window. Standard vector databases fail here, completely missing the structural topology required for multi-hop reasoning. To prevent failures, a Neo4j knowledge graph converts the extracted document into multi-layered relational networks, mapping explicit causal linkages between isolated entities. As multiple autonomous agents operate simultaneously on the same orchestrator project, real-time state synchronization becomes mandatory. To maintain coordination, the system deploys a 0MQ message bus. This directly connects the Hamza voice server, the Rust orchestrator, and all specialist background agents on a single communication plane. When Hamza logs a lesson in the memory file, a synchronized update event is instantly broadcast across the 0MQ bus, updating every connected instance simultaneously. If simultaneous write locks hit the memory files, the system triggers a failure mitigation strategy for dossier write collisions. It relinquishes the lock thread, caches the events in a local buffer, and retries writing sequentially after a 20-millisecond delay, preventing file corruption. An agent's mind is only as effective as its synapses. This tripartite architecture ensures the entire decentralized network operates on a single, perfectly synchronized state of truth. If we isolate the CEO mode parameters in this architectural schematic, we find the ultimate purpose of this persistent context: executive authority. Specifically, the authorization of disagree mode. Disagree mode empowers the AI to actively reject commands. If a developer proposes a suboptimal curve or an adjustment violating established budget caps, Hamza halts the process, demanding a structurally sound alternative. Granting an AI the authority to overrule human engineers introduces massive risk. Non-deterministic large language models are prone to hallucinations, requiring an absolute containment protocol. Denari secures this authority using a double-gate verification pipeline. Gate 1 is the speech gate. Before reaching the text-to-speech engine, generated verbal output routes through a logic guard engine. This neurosymbolic parser filters the sentence structure against classical syllogisms. The output is strictly cross-referenced against the hard constraints established in the boundaries dossier. If a spoken sentence proposes logic that violates these constraints, the text is blocked and sent to an autocorrect loop. If this logic verification process exceeds a 150 millisecond timeout, the system executes a protective fallback. It halts processing, bypasses non-critical evaluations, and defaults to a pre-signed safe conversational format. Mathematical verification, not conversational language fluency, is the mandatory prerequisite for granting an AI verbal authority over complex engineering environments. Transitioning from verbal output to systemic action requires even stricter security. If a compromised agent attempts unauthorized tokenomic adjustments, the entire network is exposed. This risk necessitates Gate 2, the execution gate. This layer protects all on-chain state changes initiated by the voice agent. When the agent invokes an operational tool call, the request is immediately intercepted by the Rust orchestrator and injected into an isolated, trusted execution environment. This secure enclave acts as a hardware-isolated verification layer, mathematically confirming all contract parameters before allowing the transaction to proceed. This provides an absolute cryptographic guarantee. The private signing keys never leave the secure enclave. By utilizing physical hardware isolation, it becomes mathematically impossible for a hallucinated prompt to alter decentralized network balances. As detailed in the top pipeline of this roster diagram, the broader ecosystem of specialist agents relies entirely on this uncorrupted execution. The quant agent routing arbitrage and the QA agent running vulnerabilities both depend on a verifiable executive truth. A CEO with memory is a CEO with intent. True multi-agent orchestration demands an identity that is mathematically structured, logically bounded, and secured by hardware.